Welcome back, everyone. Chapter 2, Solving Linear Inequalities. Just a recap on standards before we get started. We've been working on these two. The first one, I can create linear inequalities and use them to solve problems we've been working on throughout the entire chapter. That's usually your word problems where you have to write the linear inequality. And then down here, our second one, I can solve linear and absolute value inequalities. We haven't gotten to absolute value yet. That will actually be 2.6, but we're still working on linear inequalities. Specifically for 2.5, solving compound inequalities, our first definition is a compound inequality. So it is an inequality formed by joining two inequalities with and or. For example, we have an intersection and we have a union. If we have an intersection, I first of all have the inequality x is greater than or equal to 2. If I were to graph that, I would have a closed dot on 2 and I would shade to the right. We also have the inequality x is less than 5, so I would put an open circle at 5 and shade to the left. Well, if I take that and make it an intersection, I would use the word and. So for an intersection, we're looking at the word and I can make the compound inequality of x is greater than or equal to 2 and x is less than 5. And what it would look like is I would have my closed dot at 2 going to the right, I would have my open dot at 5 going to the left, and anything that was not both greater than 2 and less than 5 would no longer be on my number line. The other thing to notice when you're dealing with an intersection and the word and is that it can be written like this as one inequality. You put the x in the middle, x is less than 5, and x is greater than or equal to 2. So that's an intersection. They also, another way to think about this is that they overlap. There's an overlapping area. Now, a union is going to be our or, either or. So an example of this, we have y is less than or equal to negative 2. So we put a closed dot at 2, we shade to the left. Y is greater than 1, we put an open dot at 1, and we shade to the right. Now, if we put these together, we have to use an or, because if you notice at negative 2 going down or positive 1 going up, there's no overlap. One is at the bottom, one is at the top. So this is an or because you can either be down here at the bottom or you can be up here at the top, but you can't be in the same area all at once. So this is an and, this is an or, and when you're dealing with a union, which is an or, you have to use the word or. You cannot write it like we can an intersection as one neat line. You have to write it as two separate inequalities using the word or.